Today, we're going to learn about regression analysis. Regression analysis is a tool for building mathematical and statistical models that characterize relationships between a dependent variable, which must be a ratio variable and not categorical, and one or more independent or explanatory variables, all of which are numerical, but could be either ratio or categorical. Let's begin by talking about simple linear regression. Simple linear regression involves finding a linear relationship between one independent variable x and one dependent variable y. Here we are asked to apply the Excel regression tool using unemployment rate as the dependent variable and cost of living as the independent variable. Let's begin by going to the Data tab, finding out regression from the list right here, and then hit OK. The input white range was the dependent variable, so that would be the unemployment rate right here. And then the x is the independent variable, that is the cost of living right here. Like always, please make sure you check the labels box right here if you selected the labels like this. So there, and then input the output range, so we can just put right here and then hit OK. So this is the output that you would get with the regression analysis tool from Excel, and this tool is very helpful in finding out lots of data and information. For example, this tool can alone help you find out the linear regression model of your data set. Here, this table and this information will be helpful to find out the linear regression model. Y is the dependent variable, so which is the unemployment rate, which equals to A is the intercept of unemployment rate, so that is right here. (9.8) plus B is the slope of the cost of living, or the coefficient of cost of living, so that is right here. Times X, which is the cost of living itself. In addition to finding out the linear regression model for your data set, this tool can be also very helpful, as it also gives you regression statistics and ANOVA. So here multiple R, which is also small r or denoted by a small letter r, is the sample correlation coefficient. The values of R range from -1 to +1, where the sign is determined by the sign of the slope of the regression line. R square right here is the coefficient of determination, and it is the measure of how well the regression line fits the data. The range of R square is from 0 to 1, and the closer the coefficient of R square is to 1, the better the line of best fit represents your data. In other words, R squared gives the proportion of variation in the dependent variable that is explained by the regression model. And adjusted R square is simply the R square that is adjusted with the sample size, so that it accurately represents the data with respect to the sample size. Likewise, you also have the p-value right here, and the significance f. Here, significance f is less than 0.05, so we can conclude that our model is statistically significant in explaining the variation in unemployment rate. Likewise, the p-value of the coefficient is also less than 0.05, which means that the coefficient is statistically a significant predictor. For instance, cost of living is a significant predictor of unemployment rate.